In today's lesson, we're going to be learning about Pythagorean theorem. As discussed in a previous lesson, Pythagorean theorem describes the relationship between the sides of a right triangle. As an equation, it is a squared plus b squared equals c squared, where a represents the length of a leg, b represents the length of another leg, and c represents the length of the hypotenuse, which is always the longest side. In our first example, we need to determine the length of this hypotenuse. I'm going to begin by labeling my triangle. This I'm going to call A because it's a leg. This I'm going to call B because it's the other leg. And this I'm going to call C since that is the hypotenuse. We already know that A squared plus B squared is going to be equal to C squared. Next, replace some of these variables with their known values. We know that the length of A is 4. We know that the length of B is 5. We do not know what C is, so that stays the same. According to BEDMAS, we need to do exponents first before adding. So 4 to the power of 2 is 4 times 4, so that gives me 16. 5 to the power of 2 is 5 times 5, which is 25. We are now allowed to add 16 and 25, which becomes 41. At this point, you might think the hypotenuse has a length of 41 centimeters. That is impossible if you look at the diagram. The side lengths are 4 and 5. It is not possible that the hypotenuse is 41. Take a close look at our last line of work. 41 is equal to c squared. I want to know what c is, not c squared. Therefore, the opposite of squaring something is square rooting it. And what you do to one side of an equation, you must do to the other side of the equation. The square root of 41 is about 6.4. Therefore, the hypotenuse is actually 6.4 centimeters. In our second example, we need to determine the length of this hypotenuse. Again, let's begin by labeling this diagram. I'm going to label that A since that side is a leg. I'm going to label that B since this is the other leg. And I'm going to label that C since this is the hypotenuse. We know that the relationship between the sides of a right triangle is A squared plus B squared equals C squared. I'm going to replace some of these variables with their known values. We already know that A has a length of 10, and we know that B has a length of 10 as well. Next, we need to do BEDMAS, which means we need to do the exponents before the addition. 10 to the power of 2 is 10 times 10, which is 100. And 10 to the power of 2, again, is 10 times 10, which is 100 as well. 100 plus 100 gives you 200. Now, at this point, you might think the hypotenuse has a length of 200 centimeters. But if you take a look at your diagram, you'll see that that is not possible, since the other side lengths are only 10 centimeters. We want to figure out the length of C, not C squared. Therefore, the opposite of squaring something is square rooting it. And what you do to one side of an equation, you have to do to the other side of the equation. The square root of 200 is approximately 14.1. Therefore, the hypotenuse is about 14.1 centimeters.